Hello guys, I'm Sir Fancy and welcome in this tutorial where I will show you how to create Pong in Unreal Engine completely from scratch, so you won't need anything than Unreal Engine. And let me show you what you will end up with. You can see that I have my player that I can move just with my mouse. If I move that ball a bit, you can see that AI enemy will try to follow it and he didn't make it, so it added up score to me. Alright, and because we are making the game from scratch, let's start a whole new project. So click on Launch on your version of engine, and we will create here a new game. That game should be just blank template, we won't need anything, and make sure that you have it in blueprints. Let's leave it in desktop and console, doesn't really matter, we don't need any starter content, and let's leave it on maximum quality. And the name of the project should be Pong_tutorial. Of course, you can call it however you want, all up to you. Alright, and first of all we need to save all this, because we have here open some level, but it's quite useless for us unless it is saved. So we will click on Ctrl S and it will create first level. Let's call it Pong_level and just save it here. And the next thing we want to do is to of course create our main character. So for that we will go to blueprints, blueprint class, and let's create here pawn. And that pawn should be called just Pong_player. Let's open it and we will open full blueprint, of course, ignore that, and we will add here our player mesh, and this time it will be just a cube. So let's go into viewport, leave it like that, and let's change its scale. We want to have it much wider, kinda like in regular Pong. If you don't have any idea what Pong looks like, I would definitely recommend you to play a flash game or just watch YouTube about how it looks like, so you have some idea what is going to happen. Let's set the scale on Y value to 2, and we can leave it like that for now, and lock the axis again if you didn't have them locked. So now the next thing is to add here a camera, because we need to make sure that we actually can see our player. And make sure that it is not attached to camera, because as you can see now it is. So we will take it and move it onto the cube, which will detach it, and you can see that it is deformed by its scale. So let's unlock it again, set it to 1, or just reset it. You could have seen this yellow arrow here, and we will put it way above the player. And we may have some problems with rotation, we will see in a moment. Right now let's just rotate it 90 degrees down, minus 90 on y-axis. Compile, and now we also need to tell the game which mode or which player and pawn it should use. So for that we need new blueprint, which will be game mode. So let's create new blueprint that you've just seen, and game mode base, and call it Pong_GM, like a game mode. And the thing is that we have here quite a lot of different folders right now, so we will simply right click, create here a new folder, and let's call it blueprints, because I am, at least for this tutorial, going to pretend that I am organized. Put it here, and we can leave level here because we will have only one. Open blueprint, and right here let's go on the right side of the screen, click on world setting, and we will find here Pong GM, which is that game mode we have just created. And as our pawn we will select just the pawn we have created, which is Pong player. So now we can click on play, right? Everything seems to work, we are playing our player, nothing happens, nothing can move, which is quite alright because we haven't set it up yet. But I can see that I have used wrong axis. On Pong player, you can see that our cube is scaled in Y axis and we need to use, I believe, X axis. So let's unlock it again, set it to 1, scale it to 2, and lock it again. And we can also scale it all down. Let's say 0.5, that should be half as big. Now if you click on play, it looks pretty much as you would expect. Maybe I would even make it a bit longer. Let's unlock it again and set it to 0.5. Alright, now let's do something with that camera, because as you could have seen, we are still working in 3D space with perspective. And Pong is 2D game, so we are going to take that camera and switch it to orthographic. Compile, click play, and that's about right. We have clear, pure 2D space. The problem is that we are way too close. For that we will open our camera again and switch this ortho with, and let's set it to 248, compile, and see how it looks like. And that's much better, I like it. You can of course edit it and put there whatever perspective or camera angle you want, but I am quite satisfied with that. So now back in the editor, what I want to do is to scale up this floor. only along y-axis. Let's go to somewhere like this. And that looks fine. So now let's make sure that our player can also move. And as in original Pong, we will make sure that he can move with our mouse. So if you move your mouse up, your player cube will move up and down. We will need to go to event graph, of course, and find event kick. From that, let's actually take our cube, that will be faster. And we will add local offset. And because we are going to be moving only in one direction, when you move your mouse up, it will move up, but only along x-axis. If you are not sure which axis it should be, let's just go into the game, find our player start, which is where you are starting, and try to move it in the direction you want. And you can see that I am holding red one, which is x, as I already know, but you can also look at this changing value. And let's actually change it to 0 and z-axis to 100. Oh, actually, let's leave it to 120. So we know exactly where it is. It will be quite important later. Alright, back into Pong. And what we want to do here is then work with this X location. But now we need to see how much have you moved your mouse. So for that we will right click and find mouse and Y value. It may be a bit confusing, but you need to use your Y value to move it along X axis. At least with this coordination setup, if you could theoretically rotate it all, but I don't think it's really worth it. It's easier to use just get mouse Y and connect it to X. So now if I click play, you can see that if I move my mouse, this cube also moves, which is just what we want. The thing is that it moves just a little bit. It's like you are CSGO Pro and move it like 600 dpi, and the only thing you want in life is rush B. So we will fix that. Let's go back in Pong player, and simply between these two things we will connect here multiply. So let's multiply float by float, and let's multiply it by 10. So it will take value how much you move your mouse along y-axis, multiply it by 10, and then add that to your current location. So compile, click on play, and that's much better. I can move much faster. We have gone from CSGO to Dota pretty much. Alright, but as you probably know, it's not really good to have your player on the center. So we will need to move it on the left, which should be actually pretty simple, because we are not using any character, we are using just pawn, so our camera is not attached to our mesh, so we can just move mesh independently. So now the only thing we need to figure out is how much you move it. We will simply click on player start, move it to left, to a location where you approximately want it, and you can set it along y-axis to about 590, so let's say 600. Click Ctrl Z, that will put it back. And now I simply need to take this character and set y-axis to -600. Compile, click play, and we got it. The thing is that he can run out of the screen, but we will fix that later. Alright, next thing should be to add here some ball that you can play with. So let's right click and add here a new blueprint class. That it should be actor, and let's call it just ball. Open it, add component, and we'll just add here sphere. This one is probably way too big, so let's set it to 0.5. And just to test it out, let's put it in the game. Oh, it's actually not that big. We could make it bigger probably. Well, let's go 0.7. So now what we will do here is to actually simulate physics. Click on that sphere, and just to be sure, make sure that you don't actually need here default scene root. So let's move that sphere and set it as default field root, basically. What we will do here is to set simulate physics, then compile. You don't need to compile as much as I do. It's kind of a bad habit of mine, I'm not going to lie. And we will also need to use constraint, because we are working in 2D space, so we want him to move only along X and Z axis. So what we will do is to simply lock like only X and Y axis, so we will lock Z axis, so he can't actually move up and down once he will receive some physics input. And now if we just put it in the game, nothing happens, because the only thing he could simulate right now is, of course, gravity, which doesn't work because he doesn't have Z-axis allowed. And let's actually put here new impulse. So we will go back in the ball, event graph, and on event begin play, we will add here impulse. Let's just to be sure take our sphere and add impulse, and we want it to always move at our player. So let's make sure that we select velocity change to on, and that impulse should be along y-axis, and let's go about 500. Just see what it does. Click on play, and I can see that it's moving towards our player, and if he interacts with it, it will deflect or go the other way around, and you can see that it doesn't move along the axis, which is just perfect. That's what we want. But you can see that we have here quite a few problems, and most of it is a setting of our physics because it has a lot of friction. We will simply need to fix that with going back into content and creating here a new folder. That should be materials, because we need to set up completely new material with specific physics settings, so it doesn't have that much friction, and it also has much higher bounciness, let's call it. Well, you will see if you press the like button. If you did, you have nothing to worry about. Let's open materials, right click here, and we will create new material, and let's call it just main material, because for the rest of them we will just create instances. So click enter, open it, and right here we will need to rewrite this physical material. So right click here, and we also need to go to physics and create here physical material. Let's click on this physical material, select, and call it just a physical material. You probably don't need to change anything. Let's open it, and these are the settings you need to look at. So if you look at friction, that's basically how much it loses its speed, its velocity just by flying, just by interacting with air basically. And we want to set it at 0 because we don't want it to lose any velocity. And then there is a restitution, which is pretty much bounciness, and we want to set it to 1. That basically means once it will hit something, it will jump or bounce from it in the same velocity as it came into it. We'll save it and just change it here in our main material. Let's look at this physical material and set it to our physical material, as you could have guessed. So now apply it. Sadly enough, compiling material is a thing in Unreal. And we will right click here and create here constant. Let's set it to constant free vector. And by default, let's set it actually to white. Then right click, convert it to parameter, call it color, connect it to base color. And we'll also change here a few things. So let's create here another constant that should be just 0, and let's connect it to roughness. Let's set to actually 0.8. Now I'm just shooting values as I'm thinking about them. They are not really that important, just to make it look kind of nice. And then value from metallic we will set to 0. So connect it right here. And you don't need to convert it to parameters. So let's apply it, and from this main material we will create instances. The main advantage of material instances is that they are much less performance heavy. So general approach is to create one main material, create as many instances of it as you can without creating new main one. So let's create new material instance, and let's call it black underscore matte. And let's create another instance that will be white. You wouldn't actually need that, but let's do it. Why not? White material can stay as it is, and black material we will simply take this color, vector parameter value, click on it, and switch it to black. I'll just remember that you actually cannot use 000 black. That's not possible. It's not possible in nature. So it's really so computers have very hard time to simulate it or to render it. So always set it to something a bit higher than 0. You would probably even get an error or something. And we are working with this material. It's not a bad idea to rebuild lighting. So click right here on that lighting just to get rid of this red error. Alright, so now what we will do is to click on our blueprints, find ball, and with this ball, let's click on sphere, and we'll change our element to main white material. You can see any change because it's still white material, but we should have different physical value. And let's test it just by playing. And you can see that it's much better right now. If it hits me, it's still moving somewhere where you would imagine it would. I'm not really sure if physical material is taken from parent to child, so just to be sure, let's select here physical material right here and set it in black as well. I would that you would overwrite it like this, but let's just be sure. You can see that it works just fine. Let's also make sure that we set it up in our Pong player as well. So we are using same material right here, white material, and when we have this floor, let's put it into black. It will take a while, but will get us where we need. Before continuing to creating AI here, we will actually need to create a new blueprint, and that should be spawner for our ball. Because it's easier to have something that spawns something else as a separate blueprint. Click on blueprint class, actor, and let's call it ball underscore spawner. And the only thing we will do here is in viewport, let's add here arrow. Make it visible but hidden in game, that's alright. And on event begin play, we will spawn actor from class. That actor should of course be ball. And the location should be our arrow, and from it let's get world transform, connect it right here. And let's say that right now, just for testing, we want it to spawn a ball every 5 seconds. So we will put here delay, put here 5 seconds, and connect it back here. So now let's take this ball, copy its location, delete it, now add here ball spawner, and simply paste its location here. So now you can see that, and it's spawning it way too big. The problem is, of course, we need to go to ball spawner and do something here. Split structure pin, connect on the location and rotation, and scale set to 0.7. Or you could have just scaled that arrow, it doesn't really matter. Now that has just the right scale. And if we wait for a bit, it should in 5 seconds spawn another one. Wonderful. Maybe let's make it a bit faster, just so we have something to play with. Every 2 seconds, because I am world-class tennis player, as you probably know. And because we are all well aware of how crash can destroy everything, let's make sure that we save all. So click on save all, save selected, and here we go. Alright, so now we have something to play with. We have here a ball, we have endless spawning balls that interact with each other, which we should get rid of, but we will do that later. Now we are going to create us some enemy. So we will right click again, create here new blueprint, and this time it's gonna be just an actor. And let's set it to enemy AI. Let's add here cube again. And you know what, I want it to be exactly on the same scale setup as cube, which we have for our player. So we'll simply click on the scale, right click, copy, go back here in enemy AI, scale, paste. Easy as that. So now let's put it in the game. Let's make sure that he's on the same coordinates as, at least on z-axis, which means 150. Set it right here. X0, we can leave it just like that. So now if you just stay, okay, didn't expect that, but you got the idea. Alright, back in enemy AI, let's make sure just that we set here the same material, white matte. And now what we will do, we need to set up his behavior. Usually we have several options to create behavioral trees and all this stuff, but we just need him to move up and down depending on where is the ball. So we will actually create that logic ourselves. Let's go into event tick, and I will do something that usually would people really hate me to do, but we are creating super simple game, so it's not that much of a problem, and I will also show you later how to make it even easier for your performance wise. After tick we will we will actually get actor of class. We can't cast just like that. Get after of class. That class should be our ball. We will take its location. So take its sphere. Get sphere. And now we will get its world location. Get world location. Right click and promote it to variable. And that variable should be ball underscore look. Connect it right here. So now we need to calm those angry people in comments and do something with this event tick. Luckily, you can, with any blueprint actor, you can go right here into actor tick and set up tick interval in seconds. So right now it's set on every tick, which means every tick of the game, in this case probably 60 per second, it will ask where is that ball and set its location, which is generally very performance heavy. So we will set it up so he does it only 0.1 per second, which means like this he will do it only 10 times per second, which is much better than 60 times per second. And we also want to use this later, so we will, from event begin play, we will actually set actor tick interval, convert it to variable, promote it to variable, call it tick interval, and I will later explain why are we doing that, and set it to that value 0.2 or actually 0.1, right? Yeah, 0.1, and make sure that we have that value set as public, that variable set as public. Simply clicking here and instance is editable, or just clicking on this eye right here. Alright, now when we have this out of the way, let's create here a new custom event that we will call every time it will get that location. So add custom event, that event should be move. And simple thing that I want to do here is to add here, oh come on, let's actually simplify it, take this cube and set it to move to, move component to, connect it under our move. And now we need to get some location. Let's start by this cube and set it to get wall transform, split structure pin, and we want to connect rotation here. And then let's take our return value from location, split it again, and then we will take our ball location, get ball location, and split structure pin. And last thing we will split is this target relative location, so split structure pin, and set it here. So what we want to do is to get x-axis location of our ball, so we will connect it right here, and then we want z and y-axis to stay same as it is, and we want it to move there in 0.2 seconds, which we will actually modify right here. Click promote variable, again make sure that it's public variable, set it to time for moving. It's kind of stupid name, but doesn't really matter. And let's leave it into 0.2, make sure it's public, blah blah blah. Oh, we have a problem because it's spawning several of them. Click back on ball, no, on enemy, where is it, ball spawner, right here. And let's destroy this part of the code that will repeat itself. So now we have just one ball, and if I shoot it somewhere, it doesn't seem to work. Of course, the problem is that we need to go back to enemy AI, and after it will take that location, because right now it was just asking that ball where the hell it is. Now we need to also set it up so it will move. So we will simply call this move custom event, put it here, call function move. And I have actually made here a few more mistakes than I would hope so. You need to use relative location from this sphere, so simply not get here world location, but relative location. And right here in that move, which is here, you don't need anything than this ball x location, everything else will leave to 0. But now if I compile and play the game and play with that guy a bit, alright, let me shoot it somewhere, you can see that he moves there and he didn't make it in time. Not a problem, because now I will show you why it was so important to make those variables public. Because right now you can smartness, or basically speed of your AI, control right here from this blueprint. Click right here on this default, and let's say that I want him to be much faster. So I will set tick interval 0.1. Oh, that's maybe a bit too much. Let's set it to 0.5, and then timer for movement, that means how fast it will take him to move to that location once he will know it. Let's set it to 0.1. It should be probably a bit scattery, but we will see. Yeah, it's a bit scattery, so let's set it to 0.2. It should be smooth enough. And now if I shoot it somewhere else, which would be much easier if I had here walls, we will do that next. Then you can see that he moves there, tries to stop it, and see you. And he actually even did that. It it just wasn't on the main map. So now what we will do is to add here walls, and we will actually use blueprint for that. Add here blueprint actor, and let's call it wall. And we will actually need 2 of them. We'll need wall up, wall under scroll up, go right in, and let's create here cube. And just under it, let's create collision, box collision, and make sure it's just a bit bigger than our cube. Oh, let's just do 40, 40, 40. Oh, that's actually not enough. 50. Oh, come on, you. Alright, let's go with 60 times 60. And now if we simply put it right here in the game, can scale it up so it actually does look like it's supposed to be there. Right, and also let's get back into the blueprint and change the material as well. So in cube we will use our main white material and then duplicate and call it wall down. And what you can actually do is to click Ctrl C, Ctrl V, still move this wall up, right click on it, and we will replace selected actor with wall down right here, which you cannot see it on the name because it's still the same, but we can rename it. Come on. But if you click on the blueprint, you can see that it's the different one. Alright, so now if I click play, oh, we can't actually see it. Alright, that's bad. It's hard to see because everything is white. Alright, let's go into materials, white material, and make it a bit less white. So we are not gonna do any, no, I'm not gonna make that joke. Let's click play just so it's easier to actually see it. Now it's a bit better. Now you can see that it sometimes happens that your AI enemy goes somewhere under the mesh because the ball would go there and it's trying to trace his location. So we will need to do something about that. So let's get back into blueprint and enemy AI. And what we will simply do is that we want him to move only to certain directions. And for that we have perfect node, which is clamp float. And now we just need to figure out what these values are for minimum and maximum. And let's just see it right here. We can try and test it. So if I move him into, let's set default on 0, and he can go up to 300. Let's go 360, and let's assume that it will be minus 400. It's not exactly in the center then, but it doesn't really matter. So he can move between minus 400 and 360. If you would have perfectly symmetrical game zone, game map, whatever you call it, then it wouldn't be such a weird value, but you can see that right now it should be just fine. He didn't even touch that, and now you can see that even though ball went somewhere to hell, he still stayed here. And I have just noticed that the ball can sometimes stop the momentum, so for that we will actually go into here linear dumpling. That's used for reducing movement, and we don't want any kind of reducing movement, so let's try to set it completely to 0 and see what it does. It seems that it kind of helps. You need to of course playtest it and try your different and possibly hit the ball. Remember when I was talking about how pro tennis player I am? I wasn't joking. Anyway, now you can see that there is one more problem that we need to solve, and look at that. We need to stop our player from going through these walls, and that's exactly what we have our collisions for. And we will use actually a very similar technique that we used with this enemy, but we need to change it a bit. So let's find our pong player, and on event graph you can see that it's always taking our mouse value, multiplying it by 10 and then adding it to delta x location. How it basically works is that if you don't move your mouse value is 0, and but if you move it up, it's plus something, depending on how fast you move it. If you move it slowly, it's like 1 plus 1 plus 0.1 or something, and if you move it fast, it's like 3 or 4. What we will do basically is to put here clamp float, the same one as we did before, and we will set it that once he will be close to these walls, we will disable either plus values or minus values. So he can move only in the other direction than he did before. So let's see how it is in practice. We will simply create here a new variable from that minimum, promote it to variable. Let's call it speed underscore min, and add here a new one, max, speed underscore max. Now we have set both of these to 0, which means that he doesn't have any value that he can move from. So once it will go here, it will set it all to 0. That means that I can't move it. However, I move my mouse, nothing happens. So what I will do is to take speed minimum and set it to minus 100. So that should mean that I can move it only in one direction. As you can see, it works. I can move it up, which is really hard to demonstrate if you don't see how I move my mouse, but you will have to trust me or possibly try it yourself. Now, if I also increase speed maximum to 100, so now it can move between values minus 100 and plus 100. Anyway, that's exactly why we have here these collisions. So let's click on our wall up, click on that box collision, and we will set here on component begin overlap, and we will also need on component end overlap. And from here we will cast to our player, pong player, connect it to other actor, do the same thing here. And now the simplest thing to do would be to take those variables. Let's set speed min and max, but I actually want to show you a trick that I'm using through the development quite often, and it helps me manage all the stuff. So what I will do is to click back on pong player. So what I will do here is to create a function. That function should be changing speed. By the way, if you wonder why I did create a function and not macro, that's simply because function can be called from other blueprint and macro cannot. So I will take here this set speed minimum and set speed maximum and connect it right here. Another huge advantage of function is that it's easier for performance. And now what I am doing right here is connecting these values to that function. Because right now what I can do is go back in our wall up, and after this event begin overlap, we will call that function changing speed and simply set it up, so we don't need to call all these variables every single time. So once player will touch this collision, what I want to do is to disable his speed that can move him up, and that should be probably this -1. So by default it's set to -100, I will set it to 100, and speed max needs to stay on 100. Let's see if I'm right. So I will move it up, and seems like I am not right. I have probably mixed them, so let's set speed minimum to -100 and speed maximum to 100 once he interacts with it. Let's try that, and you can see that it seems fine. Alright, that works. So now what I need to do, once he stops overlapping this, I want him again to be able to move up and down. So I will simply take it again, connect it right here on our event end overlap, which we have created before, and set it again to 100. So now if I go here, I can again move up and down however I want, but you can see that I can't really pass it. So now let's do the same thing down here. And because we have same names for everything, let's just copy that, open wall down, and just paste it. It should work just fine. Just to make sure, yep, you can see that it created these overlap events. And we just need to switch it this time around. So let's maximum set to 100 and minimum to 0, and the other one should stay the same because that enables you to move however you want. So let's see if it works. Alright, and however I move my mouse, I can't move more than this. That's just great. Alright, now we have main map pretty much done. So what we will need to do is to create score and all this stuff around that. So we will start with actually creating a HUD. So let's right click, going into user interface, and add here widget blueprint. Let's call it main HUD. So let's add here just score. So we can open it and add here text. We'll need first one, let's call it score left and score underscore left. Let's scale it up a bit, so size of font in appearance will be to about 35. Let's make sure that we set anchor point to center. Alright, put it here. Now let's right click, duplicate it, and set it to score under scroll right. Alright, compile and move it a bit on the left side. So now we also need to some way to count that score. So for that we will create new collisions. So again, new blueprint. That blueprint again should be actor, and let's call it score under scroll left. So let's add here a component and put here box collision. And since it's score left, let's put it here. Alright. And again, create here on event begin overlap. Put it here on event begin overlap. Cast to ball. Connect to other actor. And first thing we will do is, once it will relay does it, we will destroy the actor. And from here we will cast to our player. We will save all score in player. So let's cast to pong player. As object, set it to get player pawn. And now before we do anything else, we need to create here the variables. So click on pong player blueprint, and variables should be score under scroll left. Set it to integer or float. Integer is probably easier. Duplicate it and create a new one, score right. By default, both of these values should be left. And here, back in score left, what we will do is simply take that score left, we will set it, and we will also get score left. We need both of them. That's simply because we need to do here plus, so we'll take integer plus integer and set it as new integer. That's a lot of integers. Alright, paste it here. And we can pretty much copy the same thing here. Let's click on here on Ctrl+C, close it all, open our... Oh, we can just duplicate it. Alright, my bad, we can just duplicate it. I thought we already created new blueprint, so let's duplicate score. Right, open it, and the only thing we need to change here is to set here score right. So we'll get score right. And also set here score right. So set score, oh come on dude. You need to take it of course here from pong player. So set score right. Compile, alright, that should be all fine. So now we need to show it somehow, and for that we will use our score. So let's click on our left block, and here we should have here text as content. Click here on binding, create binding, and we need to get this value from somewhere. So we'll go to event graph, and we can do it actually under event tick. So let's from our event tick cast to pong player, get player pawn. We'll take here our get score left, and also we will get our score right, and promote it to variables score left under scroll hat, just to have different name for these variables. It's easier like this, and we will do the same thing here. Right click, promote to variable, and it should be score right under scroll hat. And make sure it's all connected, because everything is connected. 5G towers, remember that. Alright, now we are here, we were creating in left text block this binding, so let's go to it, and we will simply connect here our score left, convert it to text, and I don't want to use grouping. That's pretty much a visual thing. So now back in event graph, okay, not back in designer, we will do the same thing here for here in content, again create binding, create, and we will connect here score right. Alright, but now we also need to make sure that it's on the viewport. So we will click on our pong character into event graph. Let's click on event begin play, and we will create widget that widget will be of course score. So from this return value, let's add to viewport. And now that should be fine. Let's try to click on play. And we have it there, but it's small and it's only zeros. If I let it go, will it switch to 1? It did, which is quite nice. You can see that if I quit it, it created a bunch of errors. And that's simply because our AI now don't know where is that ball we are talking about. He should get its location and he's like, what? I don't know about anything. So what we will do here in enemy AI to create here quick fix for that. Because we will need just a split of a time before we spawn a new ball, and that will be simply done right here. After we will cast to it, we will put here node is valid and connect this return value to it. And if it is valid, it will continue. If it is not valid, it won't do any compile and see if it works. Move down, switch it to 1. If I close it, no error. Congratulations, guys. Alright, let's actually quickly change this. I want to have it much bigger, so size should be, let's go for like 60 maybe. And just a preview set to 0 and 0, so you can really see how it will look like. So now I of course forgot to add our score right here. So I need to add it as well. Because otherwise it would be kind of unfair, you couldn't really score anything. One more thing we will set up right now is creating new ball after you will score. First, let's go into ball spawner and simply add here custom event, again, my favorite thing to create pretty much. And let's call it spawn next ball. Try to move it all around so you can actually see what you are doing and simply connect it here. Alright. Oh no, we will actually do one more thing. Just to make sure we don't want to spawn it right when you call it. We want to wait for, let's do 1 second and then spawn it. And now the only thing you need to do is to go into score left, get actor of class. That should be, of course, our ball spawner. And call our event spawn next ball. Then copy it all. Let's go into score right here. And connect it right here. So now, once your ball will disappear, you need to wait for 1 second and it will spawn new one. Always up to you, and you can score, as you could have seen. You just needed to slow him down for like 2 seconds to be able to do that. And I would actually really like to see what you can do with that from now on. Like a lot of what kind of different features you can do, how visually you can change it. So if you create something interesting, feel free to join the Discord and share it with me and with everyone on the Discord. We have there some pretty smart people. So if you are stuck on something, I'm sure that you can get help there. Just make sure that you use proper channel on Discord because some people still don't seem to get it. Anyway, if it was really helpful for you, I would really appreciate your support on Patreon. And that's about it. Hope it was helpful. Surfancy out.